Let's start our lecture number 15. Till lecture 14 we have seen that how to get to phase diagram from free energy composition diagram, and that too getting to the equilibrium concept. That means where the chemical potential of a particular component is same in both the phases at a particular temperature and pressure. Now we would look into free energy composition bit more, and we have to look into this free energy composition in depth and understand that if we have some particular composition, if we start with some particular composition of an alloy from liquid state, let us say in the beginning let us consider the liquid state, and then if I consider a particular composition, whether that composition would yield solid phase, that means the nucleation of solid alloy would be possible in that particular liquid at a particular temperature between the melting point of two pure components. Now we have seen the phase diagram, that isomorphous phase diagram. This was the isomorphous phase diagram what we have drawn. This is TMA, this is TMB, and this is temperature, this is XB this way, XA this way, this is pure A or B, this is liquid plus solid, this is solid. Now let us consider at a particular temperature what is the free energy composition plot. So if I see the free energy composition plot, so let us say this is G2 liquid, this is G2 solid, this is G versus XB, and if temperature is less than TMB and greater than TMA, we would get this particular free energy composition plots. Now from our earlier discussion we can see that if we have a common tangent, these two compositions are in equilibrium at that particular temperature. So this is XB of liquid, so this is XB of solid, these two compositions are in equilibrium. At the same time, in our previous discussion we can also see, let us say if we have one particular, this is some G2 line of some one particular phase. For example, let us say I consider a liquid phase, let us say that is a liquid solution. So this is pure A side, this is pure B side. I just put a line here just to refer this particular free energy composition diagram with reference to this straight line. Now any composition if I start with, let us say I start with some composition this X0 with reference to B. So that means this is composition in terms of XB. Now at this point if I draw a tangent, this tangent is passing through this point, this is nothing but G2 of liquid at composition X equal to X0, and this is mu B of liquid, this is mu A of liquid. This is very clear. Now, we have also seen that if I would like to go from this composition to any other composition on this particular line, then I have to follow a reversible transformation. Let us say I would like to reach to a composition x1, so then I have to add B, I have to add B atom to this particular composition, so add B atom to x0 composition reversibly. That way we can follow this particular line, and we can see that this particular point, that means if I reach to x1, then my composition trend would be nothing but x equal to x1 from G2 x equal to x0. But remember, whenever I am doing this transformation, actually I am following equilibrium condition and the system remains in liquid, only thing is the composition is changing. Why? Because G2 x equal to x0 can be written as 1 minus x0 mu A liquid plus x0 mu B liquid, and we can write it xa plus xb, since this is liquid, so I can write it as 1, and here this is nothing but x0 equal to 1, so I can write xal equal to 1 minus x0, and remember this is all are liquid compositions. Now, if I try to move from here to this point to this point, then my G2 x equal to x1 would be 1 minus x1 mu al plus x1 mu bl, and then I can say that G2 x equal to x0 is in equilibrium with G2 x equal to x1, and remember both are liquid phase. Why I can say this statement? I could see that from these two equation, I could see that for both the free energy cases, mu A L when x equal to composition x0 equal to mu A L when this. Similarly, mu B L x equal to x0 equal to mu B L x equal to x1. So, as per our equilibrium concept, that means these 2 points are in equilibrium. These 2 points are in equilibrium. So, these 2 points means this one as well as composition x1 and x2 x0 are equilibrium. Similarly, if I try to go this way and if I reach, let us say, x2 composition, then what I have to do? I have to take out B from x0 because it is going towards A reach side, from x0 reversibly to reach to this particular G2 x equal to x2 point, and there also this particular equilibrium concepts are can be validated. So, we see that if we take any composition in this entire composition range, then that composition can go to any other composition keeping the liquid phase as a liquid phase along the tangent line, and those all composition will be in equilibrium. Now, if I now combine this particular on this particular phase diagram, this G versus X diagram, if I introduce one more phase, let us say I introduce solid phase on this particular diagram, let us show. If I put it with, let us say, different color, let us say red color, let us say I put a solid line like this. Do we think that solid would be able to nucleate from this liquid, particular liquid compositions? And in order to do that, we have to see that whether these solid line, this is G2 of solid, that is the solid solution, that line, whether that is below this particular tangent line, this, let us say I consider it is as M and N. See, this M and line, we have to see that whether that line is above this particular red solid solution line, or some portion of this Mn line is, just reiterate this, we have to see whether this Mn line is above this solid free energy line or Mn line is below the solid free energy line. Now, if I have to form this particular, let us say this composition, I need to form a solid, and then I have to reach to this point in order to get solid. And if I would like to reach there to get a solid, I could see that the free energy is actually increasing. For any process, that means here the solid X0 composition, liquid, if I try to follow X0 of solid, that means the X0 composition is converting into solid X0, then I am saying there is a increment in free energy. And as this particular process is done at particular composition pressure, until unless we see Pt less than equal to less than 0, the process cannot be spontaneous. And if we see Pt greater than 0, this is for spontaneous process, and this is for non-spontaneous process. I see that if I have to go from solid liquid line to the solid line at the same composition, I see there is a increase in free energy, then that process cannot be spontaneous, rather that kind of process cannot be possible thermodynamically. Similarly, if I try to see at any point with reference to this Mn line, everywhere if I have to get solid, I have to increase the free energy, which is not thermodynamically feasible process. That means, if the condition of or the position of the solid solution line and liquid solution line are such as it is dictated in this particular picture, solid phase will not form, because everywhere I am seeing that there is an increase in free energy, which is not thermodynamically feasible process. Now, situation could be different if I change this particular point position, that means initial alloy composition, if I change from this side to this side, that means initial composition. Let us see what happens there. Now, I can draw the similar diagram. This is G2 of liquid, this is G2 of solid. Now last time we considered the composition here, so that is what this is mu B L, this is mu A L, and every time we see that any composition starting from M and N would not lead to solid phase formation, because every time I see that in order to form solid I have to increase the free energy. But now if I start changing the initial composition when the temperature, let us say I take a particular alloy, I take it beyond melting point of B, that means everything would be liquid and it will be miscible all the time, and that composition if I drop, gradually I can also change those composition as per my wish, and if I shift this particular composition on this particular G2 line, and everywhere if I keep drawing a tangent, there will be a point when the tangent on the composition of the liquid solution would cut the solid solution free energy line at a particular point. So that means it becomes this tangent, which is let us say SQ composition, SQ tangent line. This tangent line is a common tangent between solid solution as well as liquid solution free energy composition line, or the graph I would say. And I could see that this composition and this composition, they are at equilibrium. So this is XB solid, this is XB liquid, these two compositions are equilibrium. So if I have to, and that moment this is at a particular temperature T, which where this SQ common tangent can be drawn on 2 points of solid and liquid lines, liquid free energy composition curve, and that time these two compositions will coexist. This is the equilibrium concept. Now as I am going from this composition and going along this particular G2 free energy curve, and once I, let us say I reach to this particular composition. So this is, let us say, composition X1. I can also draw a tangent at that point over this G2 line. So if I draw that, this is that line. I could see the right side of this particular composition X1, every time the solid G2 line is above this tangent line on this X1 composition. I can term it as GH. So if I try to go on the right side, every time I see that I have to increase the composition to reach to the increase the free energy to reach to the free energy line for solid. So that means right side of X1 no solid phase. Since there delta GPT greater than 0 for liquid to solid formation. But on the left side of it, left side X1, situation would be different between this point to the left of this point. So, now left side of it I could see between this to this point G2S is less than, and if I give a notation to this point as F, GF portion of GH line, and GH line is what? GH line is tangent on X1 liquid solution, is indicating all the compositions of liquid in equilibrium. Hence, between G and F line, between these I could see that there is a situation where this condition is met. So, spontaneous solid solution formation from liquid solution of X1 is possible, and this possibility is possible means thermodynamic possibility. So, again if we go back, I could see that when the composition is taken, composition of the initial alloy is taken at this point, at no point between pure A to pure B I could get solid phase, because every time I have to increase the free energy, which is indicating that the process or the transformation is non spontaneous. So, no solid phase formation thermodynamically. But when I reach to this composition XBS and XBL, yes, there is an equilibrium between solid and liquid, and these two compositions of solid and liquid would be in equilibrium. We cannot definitely say that whether solid would form or not, because that time the free energy difference is becoming 0. But once I take the composition between XBS and XBL, let us say X1 here, I could see that some portion of that tangent line on X1 is above the solid solution line, and that leads to the condition which is del GPT, liquid to solid transformation is less than 0. So, that means it indicates that thermodynamically this is a feasible process, and we could see solid phase formation from liquid. Now, interestingly, if we see that from this G to F point any compositions can be possible, but now we have to decide which phase has the highest probability to form, and that can be decided by the difference in free energy. Now, if we see this difference in free energy, I have to just find out where the difference of free energy between this GF line and G2 of solid line is maximum. That phase would like to nucleate first from the liquid composition of x1. So, now if I write it down, then the maximum free energy difference between GF and G2 solid, that particular composition of solid solution would try to nucleate from liquid solution of composition x1. This is a very important aspect, because finally why we are doing all this, we have to calculate what is the free energy difference when a particular alloy is taken and the second phase would appear. So, that free energy difference for the second phase, which is termed as delta Gn, how to find that particular value, and this gives that indication that what should be the value of that particular delta Gn or free energy for nucleation. Remember, free energy of nucleation and the free energy difference for nucleation or free energy difference for overall transformation, these two are entirely different quantities. We will discuss those part little later, but first let us understand this particular issue, that why we have to draw a tangent over that composition point on a liquid line in the case of liquid solid transformation for an alloy, and then we have to consider those compositions where the tangent over that composition line on G2 of liquid is higher than the solid free energy line, and that is what we have considered here. Now, the same concept can be used to find out that if there are two solids which are possible in a system from a particular liquid composition, then which solid would appear, that can also be found out by constructing free energy composition diagram for liquid as well as both the solids. Let us say I consider a situation like this. This is my liquid line G2 liquid, and there are, let us say, two solids which could be possible from the liquid. One is, let us say, G2 of solid 1, the another one is, let us say, G2 of solid 2. If I start with the composition at this point, then again I have to draw a tangent on that particular point. This is G versus XB, and here also I could see that from this below this particular portion of that tangent on this composition x0, this is the initial composition of the liquid what we have considered, S1 free energy line is below that, between this to this. So, this particular solid 1 could be a possibility, but what happens to S2? But if I try to see S2, every time if I have to form S2 from that particular liquid composition, I could see that there is increase in free energy. So, for S2 delta G Pt greater than 0, for S1 if I give a notation as OQ, S1 delta G Pt between OQ less than 0. So, S1 is possible, S2 not possible. So, the S1 could form from the particular X0 composition if the situation is this, that means this is at some temperature T, pressure equal to 1 atmosphere. So, that time S1 is a possibility for the formation from liquid, but S2 cannot form, because for S2 formation I have to increase the free energy, which is not possible. So, this also gives an indication that which phase would come out from a particular composition of liquid. So, we will just take it up in our next lecture and discuss more on this, and finally, we will start counting what is the free energy for nucleation in case of alloy systems. Thank you.